So, in this lecture, we are going to start with Skolemization. Now, see why we need Skolemization. Okay, so in first order logic, if I want to change something in first order logic, if I want to apply resolution, okay, if I want to apply resolution, then I need to have the given statements in CNF form. Okay, so in CNF form, existential quantifiers are not allowed. In CNF form, existential quantifiers are not allowed. Not allowed. Why they are not allowed? Because in existential you can see that we don't want any quantifiers, right? If it is given that there exists some x, p of x like this, then we don't know about which x is going to satisfy it. Okay? So the main purpose of Skolemization is to remove this existential quantifiers. So this is the definition in first order logic. Skolemization is the process of eliminating existential quantifiers by introducing new function symbols or constants. So let us say we are being given this statement, that is, for all x there exists some y and p of x comma y. So what it says, for every x there exists some y depending upon x. Okay, because इसका क्या मतलब है, there for all x there exists some y, that means y is dependent upon x, so we can replace y with a function of x, that is for all x p x comma f of x. This f is called a Skolem function. ये f of x कहाँ से लिखा हमने, क्योंकि y को हम बोल रहे हैं we can replace y with a function of x, so इसे हम बोलते हैं स्कोलेम फंक्शन. अब हमारे पास एक एग्जांपल है, फॉर ऑल एक्स human, if x is a human, then it implies that x loves y, that means human loves y. So the first thing is to remove implication, right? Remove implication, and you all know that how we remove implications. So I will write it like this: for all x, negation of human x, and then और के बाद क्या आएगा, it will be existential y love x comma y, right? Now we will do Skolemization. So अब अगर हम Skolemization करें तो हम पाते हैं कि for all x there exists some y, that means y is dependent upon x. We can write since y depends on x, we can replace y with f of x. Okay, so what we will do here is, for all x there exists और, and now there exist जो existential है that will get removed, because हमारे पास अब कोई y वाला वेरिएबल हमने हटा दिया. ठीक है, तो it is now not needed. Now we can drop this also. Okay, we can drop this also because in CNF form it is true for all the values of x, right? It is by default true for all the values of x. So we can drop for all symbol, and hence what we get is human x loves x comma f of x. Okay, and now this is ready for resolution. This is ready for resolution to be applied. Okay, so I hope it is clear that what is meant by resolution. Now let us if you are having the confusion that why this is allowed, okay, so if you are having the confusion that why dropping for all is allowed, So this is because in first order logic, after a Skolemization, okay, in first order logic after a Skolemization, all the remaining variables are universally quantified. That means all variables are implicitly universally quantified. After Skolemization, in FOL, all variables are implicitly universally quantified. That means they are true for all the values of x. Okay, therefore we don't need to write for all symbol here. Okay, so it becomes unnecessary. That means if it is given that for all x px, so we can say that pa, pb, pc, if we are having three values of x. So in resolution, if we use a clause like p of x, okay, then we can substitute in place of x with any term. So universal behavior is already built into the resolution. Okay, universal behavior is already built into the resolution. But one thing that you should remember, that you can't drop existential before removing their exist. Okay, this should be noted. Now let us see one example. That how we can convert a first order logic statement to a CNF form. Okay, so convert into CNF. This is given to us. Okay, convert into CNF, and the statement is anyone who likes all animals is liked by someone. Anyone who likes all animals is liked by someone. So basically, what is the input? If I convert it into first order logic, then the input given to us is for all x, for all y, animals y loves x comma y. That means x loves y, and what is y? Y is all the animals. Okay, so if this is, then it implies that there exists some y that loves x, right? So this is the input, and now I want to convert it into a CNF form. So the first step is eliminate implications. So how I will be eliminating implications? You all know. So I will write for all x, negation of for all y, then animals y, then loves x comma y, and then or negation of y loves y comma x. यहाँ हमने क्या किया? What we did, we actually removed this implication. Now I will be removing this particular implication. Okay, so what I will do is for all x, negation of for all y. Now here negation will come. Okay, so negation of animals y, and then here or will come, loves x comma y, and then here existential quantifier y loves y comma x will come. Okay, now what to do? Now we are free from all the implications. So the next thing is push negation inwards. Now what I want is I want to push the negation inwards. So if I push this negation inward, it will become for all x, as the negation will go inside, this will turn into there exist. Okay, there exists y, and then this negation will get cancelled. So it is simply animals y, and then this or will get converted into and then there will be a negation before this loves x comma y. Okay, and after that there will be or, there will be or, and then there exists y loves y comma x. Okay, so now we are having this. Now what I have to do is standardize the variables. Okay, standardized variable means here already we are using y and x, so here we need to change the value of y to something else, right? So what I will do here is for all x there exists y, animals y, for all loves x comma y, for all negation, for all नहीं, ये तो और है, negation of z loves z comma x. So what I did is, this is known as standardized variables. Okay, why we did this? Because y and z, now because there were two y. Okay, so now y and z are functions of x. Okay, so what I can do is, now I can replace existential quantifiers. Now I can replace existential quantifiers or existentially quantified variables with existentially quantified variables with Skolem functions. ओके, सो हाउ, क्या होगा यहाँ पे? y की जगह पे आप लिख सकते हो लेट अस से y ऑफ x और z की जगह पे z ऑफ x. दैट मीन्स y को आई एम गोइंग टू रिप्लेस विद y ऑफ x एंड z को आई एम गोइंग टू रिप्लेस विद z ऑफ x. Okay, so here it will become for all x animals देखो यहाँ एनिमल्स में क्या था, यहाँ एनिमल्स में y था, राइट? सो आई एम राइटिंग हियर y ऑफ x, और ये एग्जिस्टेंशियल हमने हटा दिया. ठीक है, जैसे स्कोलेम फंक्शंस यहाँ पे रख रहे हैं तो एग्जिस्टेंशियल का फिर कोई मतलब नहीं रह जाता है. देन लव्स okay, there was a negation here, so loves x comma f of x comma y of x. Okay, and then I'm going to close it, and then we are having or, and there exists some z, there exists some z, so there exist will get replaced here, there exist will get replaced. What will be there? It will be loves, and replacing it with the Skolem function z of x and x. Okay, so here capital Y of x and z of x are Skolem functions, are Skolem functions. Okay, now the last thing that we will do is distribute or over and. Okay, so we are going to distribute or over and this will lead me to for all x animals y of x, this is a Skolem function, and then or negation of loves, and this is no, here there will not be negation because now we are bringing this particular loves inside, we are distributing it. So loves z of x comma x and here it will be negation of loves x comma y of x, and then it will be or loves z of x comma x. Okay, so this is the first order logic that has been converted into CNF form. So now what we will do, we will remove the universal quantifiers. Okay, why we are going to remove universal quantifiers? Remove universal quantifiers. Okay, so we discussed that why we are removing this. Then it will be animals y of x, and then loves z of x comma x, then I will be closing this bracket, and then it will be and then it is giving me negation of loves x comma y of x or loves z of x comma x. Okay, so this is our final result. Now we will quickly see that how we can define the resolution. Okay, how we can define, or we can see the definition of resolution, because now we are ready with our two concepts, that is substitution and unification. So if it is given that f1 or f2 or till f of n, and then there is a symbol p, and after that we are given negation of q or g1 or like this up to gm. Okay, so what we will do here, this will substitution, that means I am using substitution theta for f1 or like this till f of n, and then g1 or till g of m. Okay, so we have replaced here p and negation of q. This is our conclusion. Okay, so how we have replaced it? We have replaced it by unification, where that means we can write theta is equal to unify what we need to unify, p and negation of q. So it will be unify p and q, right? So this will give you a theta, and then by that theta you can write the conclusions. Okay, so let us take one example. Example is animal y of x or loves z of x comma x, and then we are having negation of loves u comma v or feeds u comma v, right? So from here what you can conclude by resolution is, animal y of x or feeds z of x comma x. How is it possible? See, in place of u I am having z of x, and how it came here? If you unify these two things, then u, in place of u if you substitute z of x, and in place of v if you substitute x. So the substitution, using the substitution, we can get substitution theta is equal to u z of x, and for v it is simply x. Okay, so I think now it is clear that what the resolution is. In the upcoming videos I will be discussing some more questions that will cover that how we are going to convert given statements into first order logic statements. Okay, thank you.